So imagine you have a coffee shop with one employee and one coffee machine, and suddenly you go viral on TikTok. Lots of new orders are coming in. How could you ensure that you can fulfill all these orders, grow and scale smoothly, and how can you address each of the issues that you're going to face? Now, the goal for this video is to understand why systems engineering is going to be mostly about managing growth, risk, and change. It's not going to be about code. So you have your shop right here. You have one employee and one coffee machine. Now, the first thing you can do to manage the incoming traffic and orders from these customers here is to work your existing resources harder. And this is called vertical scaling. So for example, you give your employee more money, make them work more hours, make them work harder so that they can manage more orders. Or you can upgrade your coffee machine so that you can make the coffee faster. And this is called vertical scaling, which is you have the same resource and you make it stronger, but it's still the same resource. Another thing you can do is preparing beforehand. So for example, you can grind your coffee beans at night. You can prepare the donuts when everyone's asleep and you're not getting any orders, whenever you have free time. And in a technical world, this would be something like cron jobs or asynchronous background jobs that you can do when you don't need the computing power, or functions that run automatically, things that you can do at non-peak hours when you don't need the processing power. So for example, processing data at night. But you might face an issue where you have one employee, you're going to have a problem where if your employee calls in sick or they can't work that day for any reason, then you have no business that day and you're not going to make any money. And this is called a single point of failure. A solution for this would be hiring a backup employee, which can be on call. So whenever this employee cannot come to work for any reason, this backup employee will fill in for him. And this is called making your system reliable, where if one node fails, that doesn't mean the whole system is going to fail. Now, there's going to be a point where you can no longer scale using only the resources that you have. You're going to have to add more resources. And this is what we call horizontal scaling, where you're going to get more of the same resource that you already have, which in this case is going to be your employees, the people that make the coffee and make the donuts. So you're going to get, say, 5 employees and you're going to get 2 backups. Now, how many orders you can fulfill and how much you can do in your system is directly linked to how many resources you actually have. And in system design, this is similar to getting multiple similar machines that can do the same job so you can do more of that job and you can handle more requests. Now, another thing that you're going to want to do is to divide your team and divide your system into different parts. So what you should do at this point is to divide your employees into 2 teams. Team A, which should be your coffee experts, and Team B, which should be your donut experts. Now, this will make each team more efficient at their job because they're going to be more specialized at their specific job. Now, when you reach this point, say you get an order for coffee and an order for donuts. Obviously, you would want to route these orders as efficiently as possible, give it to the appropriate team for the job. This makes the system simpler and easier to use. And anytime you need to know something about a specific order, you know who to ask. Or anytime you need to change a product, so you want to change the donut recipe, for example, you only need to inform the team that is responsible for the donuts. And this is what we call a microservice architecture, where you have well-defined responsibilities for each part of the system. Now your shop is highly scalable and can manage all orders efficiently. But what if you can't use that facility for an electrical outage or some sort of emergency that prevents your shop from working that day? Then you will have no business that day. This is why you want to distribute your system. So you make a second shop that can do all the functions of the first shop and put it at another geographical location. And this is what we call distributed systems. In this scenario, the orders will come in and they should be routed to whichever facility is closest to them. But say shop A cannot work that day for any reason, then in that case, they will all be routed to shop B. This once again adds reliability to your system. Now, in a large scale system where you get requests from all over the world, you're going to have to put local servers everywhere around the world to make sure that the response time is very fast and to have fault tolerance. Now, say you have shop A and shop B, and the customer makes an order, and that order should be sent to either shop A or shop B, depending on which shop can fulfill the order faster. But the customer isn't the one that should be managing this. This should be managed by a separate entity, which is only responsible for routing requests. It should definitely not route them randomly. It should have one clear parameter, and that is how long will it take for the customer to get their order. And this is what we call a load balancer. where the requests will go into the load balancer, and the load balancer, as long as it is receiving real-time updates from shop A and shop B, it can determine which shop to send the requests to and make intelligent business decisions. And let's say now we also have a delivery agent. We can now deliver orders. The delivery agent is only responsible for delivering the orders, and the only responsibility of the shops is to prepare the orders that the customers want. Now we can see here there is a clear distinction and a separation between responsibilities. The delivery agent does not care what he's delivering, and the shops do not care who is going to pick up the order, whether it's a delivery agent or the customer is picking up the order themselves. So we can see that the delivery agent and the shops have nothing in common. This is why we want to separate the responsibilities between the two. This is what we call decoupling, a separation of concerns, which we do in order to be able to handle separate systems more efficiently. So now we have this separate system here, which is only responsible for making and preparing the orders, and this separate system, which is only responsible for delivery. Now, the next thing we want to take care of is logging and metrics. Now, imagine something happens with the shop where one of the coffee machines stops working, which causes the shop to take longer to fulfill the orders, or a delivery agent has his bike break down and he can no longer make the deliveries. Now, this will make the delivery agent slower as well. This is why at this point you would want to be able to log everything, which means you can track everything that happens and when it happened, and later use this data for reporting, metrics, analytics, auditing, and even maybe machine learning. This is also what's going to help you future-proof your system. Now your system is scalable. We've defined all the problems we faced and how we can solve them. And this is what we call high-level design. Now we're done creating our system, but there's one more thing we should pay attention to, which is extensibility and flexibility. Now, the thing is, you would not want to rewrite and recreate your entire system to solve a similar problem. So you should design and develop your system in such a way that it can be used for different purposes. Now, I hope this video has helped clear up some concepts when it comes to system design, because I know I definitely had a hard time understanding what system design really is, why it is important, and how it can help us solve problems.